Okay, so I just want to review the difference between quadratic formula and complete the square. And the key thing is complete the square. It's a lot more steps, but the basic idea is we're solving for x using algebra. So we want to get the x by itself, and if you're ever stuck on these ones, we're going to use SAMDEB. And if it looks familiar, it's basically BEDMAS backwards. If we have all the numbers, we use BEDMAS, the order that we do it. If we're doing algebra, we always go backwards. So we're going to start with the adding, subtracting, finish with the brackets. So what we want to get to is this point where the brackets are by itself, the numbers on the other side. We can't do brackets first, we have to start with the exponent, then the brackets. So in this case, the opposite of a square is a square root. They cancel, but we have to square root the other side. In this case, we just end up with x minus 4. These two cancel out, and square root of 49 is plus or minus 7. And that's the key thing. There's two possible answers. Now the brackets are gone. They disappear once everything else is gone. And to move the 4 over, I'm going to add 4 to both sides. So in this case, I got 4 plus 7 or 4 minus 7. And so I end up with two possible answers. So again, we're just using algebra. We're going in this order, SAMDEB, to solve for the answers. And in this case, we have two possible answers. So this one here, there's a number on the same side, so we have to move it over. Once we move it over, then we can square root. So again, we can't square root when there's something on the same side with the brackets. Square root both sides. And don't forget the plus or minus. Now we have to move the 7 over, so we subtract 7. And I have two possible solutions. Negative 7 plus 5 is negative 2. Negative 7 minus 5, two possible answers. This one here, the number's on the other side. There's nothing outside the brackets other than the exponent, so I start with the square root. Plus or minus, always. And this time, I don't have a perfect square. So this time I just leave it in the radical. So now that we've taken the square root, we realize we don't have a perfect square. So we're going to move the 11 over. And if we have a radical on the other side, all we can do is simplify it if it's possible. We're going to look for a perfect square that goes into 7. 7 is a prime number. Nothing goes into it. So we leave it like that. Do not use decimals when we have these problems. Now the ones that are harder. Everything in the first row had the square done. It had the brackets, it had the square. Now we have general form. We have a trinomial, and if we can't factor it, we have to complete the square. We're going to make y 0, and we're going to move the 11 over. Now, negative 11 will move over and become positive 11. We're adding 11 to both sides. And the key thing here is we're going to take this and try and form the perfect square. What number has to go there so that we can factor this? To figure it out, we take 8 divided by 2 and square it. So 8 divided by 2 is 4. 4 squared is 16. And if we add 16 to that side, we do it to both sides. So on this side, we get 27. And if I factor this, I get my perfect square. So I'm trying to turn it into one of these, where we have the perfect square equals a number. We have a perfect square equals 27. Square root both sides. Don't forget your plus or minus. And now we've got a radical. It's not a perfect square, so we've got to look for a perfect square that goes into 27. And if you think about it, 9 times 3 equals 27. So this one here is going to become, the square root of 9 is 3, and the other 3 stays inside. It's a plus minus, and I'm going to subtract 4 to both sides. So my final answer has a radical minus 4 plus or minus 3 root 3. So just to go back, we make y 0. We move the number that we do have to the other side. I always put it onto the right side and keep my trinomial on this side, on the left. So in this one, I'm going to make this 0, and I'm going to move the 21 over. And that will actually be negative 21 because we're going to subtract 21 to move it over. Take this, divide by 2 is 18. 18 squared. So in this one, I make my perfect square. I added 324 to both sides so that I get x plus 18 squared. I'm going to square root both sides. Now we're pretty much done. We've got a radical, so we can't turn it to a decimal. It's not a perfect square. The only thing I can do is check my perfect squares to see if any of them go into 303. So I've just made a list, and I'm going to go through and check. Now this is a pretty big one, and it's an odd number, so it has to be one of the odd ones that goes into it. 25, definitely not. 49. And so you'll see that once you go up, nothing goes into 303. Nothing that's a perfect square. So that's my final answer. So this one, make it 0. Smaller numbers, so this one will be easier. And the 7, I'm going to add 7 to both sides to move it over. Divide by 2 and square it. I'm going to add 4 to both sides. Now this one's negative, so be careful. It's going to be x minus 2 squared, but we always add a positive number. Negative 2 squared is positive 4. We add 4, positive 4 to both sides. Square root. Make sure you get the plus or minus. Add 2 to both sides. 11 is a much smaller number. We know nothing goes into it. That's a perfect square. We're done. So now we're going to switch over to the quadratic formula. We're going to use the formula. ABC So this becomes a perfect square. 49 minus 24 is 25. The square root of 25 is 5. Because it's a perfect square and the radical disappears, I'm going to add both situations. Negative 7 plus 5 is negative 2. Divided by 2 is negative 1. Then I'm going to do it again with the minus 5. Minus 7, minus 5, minus 12 divided by 2. I get my 2 answers. So if you can take the square root, put it in, and calculate both answers individually. So this one is not a perfect square, 33. So what I need to do is look at my perfect squares. 4 doesn't go in, 9, 16, 25, nothing goes into it. So I'm done. Make sure you have the plus minus. That's it. This one has a negative already, so be careful with it. It's going to become positive 5. Now this one I'm going to stop here because I see the negative. The radical has a negative inside of it. Can't do that, so it's no solutions. It's not possible. So when we decide whether it's complete the square or quadratic formula, the key thing here is, and the easy ones are, if it's in vertex form, automatically complete the square. If it's general form with weird numbers, decimals, fractions, automatically do the quadratic formula. Trying to complete the square with kind of numbers like this just makes it really hard. The harder one to decide is when it's general form and it's nice easy numbers like these two. So the key thing here is, if you can divide by 2 and get a nice number, if it's an even number, complete the square. If we do quadratic formula, we could use it, but we are going to have to simplify the radical. That's the one thing to be warned about. This one here, it'll be hard to do with complete the square because we're going to get a decimal. So this one, quadratic formula. And usually if it's odd in the middle, quadratic formula doesn't require any simplification. Whereas if it's even in the middle, you will have to simplify. Complete the square, not as hard. So the final two we're actually going to solve. We have to decide which ones to use. As soon as I see small numbers like decimals, I am going to use quadratic formula. So, got my A, B, and C. The B is negative, so it's going to be negative 11. So if I go through a check, I can check my perfect squares. Nothing goes into it. So this is my final answer. This one here, I've got the brackets already done. I am going to go straight to complete the square. I've already got the square. I just need to move the other numbers to the other side. The key thing is we've got a number in front, so just be careful. We're going to move this one over first and then move the 2. Always do the opposite. Do it to both sides. So in this case, the y becomes 0. And it's minus 50, so I'm going to add 50 to both sides. To get rid of this, I have to divide by 2. And because it's in front of the brackets, I don't have to divide these by 2 because of the brackets. This disappears, and I get 25 on this side. Now, square root. It's a perfect square, so it works out nicely. And so now I'm going to do my two options. Negative 4 plus 5 and negative 4, negative 5. My two answers.